Hey everyone, my name is Drake. Today I'm going to be showing you my submission for HackEd Beta. It was a hackathon that my computer engineering club at my school put on, and we ended up getting third place, our team, so I'm pretty proud of this project of mine here. So just before we start, a brief description of SimpleLogic. It's a Boolean algebraic expression calculator, but it also lets you visualize Boolean expressions by generating their timing diagrams. This was inspired by a class that I had taken last semester. It was a digital logic design course, and in that course we did lots of simplifying Boolean expressions, either if it was just by using Boolean algebraic laws or Carnot maps. Either way, it was a very long and tedious process, so SimpleLogic was inspired by that class to help streamline the process and make it quicker to derive simplified Boolean expressions. So now we are going to get right into the visualizing expressions portion of SimpleLogic here. So we're going to go ahead and hit the Visualize Expressions button. And you can see that we're greeted by a few new buttons that we didn't see on the first page and a text field. So the first thing that we're going to do is click the Instructions button. The instructions tell us that the program works for up to and including 6 variables, and it also tells us some operators we could use in place of or, and, or not, which are Boolean algebraic operators. So we're just going to go put those away for now, and we're going to give this text field an expression that I have stored in my clipboard here. Now we're going to hit Visualize, and you see that it generates the timing diagram for this expression. And just to confirm it works, we can easily pick a combination. Let's pick when A is low, B high. That should give function as high, and as you can see, it works correctly. So now we're going to move on to something a little bit more complicated so we can get the full picture of why this can be useful. This here is a 4-variable expression, and we're going to visualize it. So as you can see, the more variables you use in an expression, the more complicated the timing diagram will get. But this is a very useful tool when you're troubleshooting your logic circuits, because you could look for any one of these combinations and you can check the expected output, and then you can go and test your circuit to see if you get the same output and compare the two against each other. And before we move on to the simplifying expressions portion, I'm just going to go ahead and click clear. And we're going to show as 6 variable expressions to show the full capabilities of what SimpleLogic can visualize. So as you can see, SimpleLogic does a great job at pumping out these timing diagrams quickly. This is very useful when it comes to troubleshooting your digital logic circuits. And if you had to draw something like this by hand in class, it would take an extremely long amount of time. As you could see, a lot of squigglies, very easy to mix that up. So this just makes the process a whole lot simpler. So now we're going to go back, and this brings us back to the main page, and then we're going to hit the Simplify Expressions button. So now that we've hit the Simplify Expressions button, it brings us to this frame. It looks very much similar to the Visualize Expressions frame, and we're just going to give the program the very first expression that we gave it for the visualizing frame. And now if we go and hit Simplify Expression, you'll see that we get some text below. On the left-hand side here, we have the minimized product of sums form, and on the right-hand side, we have the sum of products form. These are two very popular ways of expressing simplified Boolean algebraic expressions through the use of Carnot maps normally. And we have some additional text here below that's very useful information, but before we get into that, I'm going to go ahead and clear this, and we're going to give it a little bit more of a complex expression so we can explain what that means. So we're going to go ahead and hit simplify. Once again, it gives us the two simplified forms of the expression. But if you look at the text below, it tells you the number of gates used as well as the number of inputs to the gates that are used. This is very useful when engineering your digital logic designs because you want to know which implementation will consume the least amount of resources. So this way, if you go produce it, a lot of these circuits, you're going to be saving quite a lot of money by using less than half the gates as, say, the product of sums implementation. So, since we use a lot more gates and inputs in the product of sums form, for this implementation, I would use a sum of products form. Now we're going to see our complex 6-variable expression, and we're going to see how good of a job SimpleLogic does at simplifying this expression. As you can see, it makes very quick work of that, and then it tells us that we used less than half the gates once again in the sum of products form. So we're definitely going to want to use this for implementing our Boolean algebraic expression. Additionally, this is very useful just because if I were to simplify a 6-variable Boolean expression by hand, this would probably take me 30 to 45 minutes. It's definitely a lot of work. So using SimpleLogic, it's very nice for telling you not only the simplified forms, but which one would be better in this case. After we get these simplified forms, we would then choose whichever one is more efficient. So we choose the sum of products form here. And then we can easily convert this to a universal gate design using NAND gates. So this has been SimpleLogic. Thank you guys very much for watching. If you want to check out this project for yourself, then I'll be linking my GitHub in the description below, so you can go and get it from there. There's also some very easy to read setup instructions, so you can get set up yourself. Thank you so much. Bye.